How's it going, folks? Today we are going to talk about databases. Specifically, we're going to talk about relational databases and we're going to talk about MySQL, but there are a bunch of other kinds out there and we'll touch on them briefly. So, what is a database? A database is, on an abstract level, used to store information on behalf of your program. So, you may have had code that's storing information as a flat file. You may have code that's storing information in local storage in a browser. Neither one of those is really ideal for a lot of use cases. In a lot of cases, you want users to be able to have the same data across browsers, for instance, or across different computers as they log in. Flat files, especially on Heroku and systems like that, can be lost whenever the server restarts. And so you want something more persistent and something that is widely available to your backend so that you can always give the user the data that they need. At a more technical level, databases are a program like any other program that runs persistently on a machine. You can run most databases, well, a lot of databases on your local development machines, and in fact, that's generally what we do when we're doing development because it's a lot easier than connecting to remote machines. But when you go to production or deploy your application, you're usually going to be using database servers that live on different computers than your actual code is running. And that's totally fine. They're perfectly well designed for that. So, there are two kinds of databases. The first is a relational database. Relational databases have a very strict definition of the data that they store. You can't store data that doesn't fit the schema that they've been given, and we'll look into how we give them that schema a little later on. You can also define relationships between that data. So you can determine that a user may own a book in the system, or there's a certain object like a shopping cart, for instance. You can define that your user owns that cart and is only the only person allowed to access that cart, which you can imagine is kind of a useful thing to do because you don't want people getting random strangers' carts. Non-relational databases at their core behave a lot like a JavaScript dictionary or object. They have a key, they have a value, and they store that key and that value mapping, and that's pretty much it. They don't usually define much relationship between the data, which is by definition non-relational database. They also don't usually have a strict schema that that data has to fit. You can change the format of that data on the fly as you see fit. Relational databases are much more rigid in that regard, and they're a lot harder to change the data format once you get it into place. And each one has their own pros and cons, and each one is used in various contexts. So non-relational databases are really, really good if you know the exact format of what you're looking for, and they're extremely quick at accessing data. So they're often used for caching because we can build cache keys in the same way every time and know to look up a cache. Relational databases, on the other hand, are really, really good at extremely large data sets, at crunching those, at finding how many users exist in a company where you have billions of users in your system. A relational database can do that in probably a couple seconds. And so each one has their own, pros and cons. And so we'll get into non-relational databases a little later, but for now we're going to cover relational ones. So, how is a database structured? The first thing is a database server, and you can see this at the top. That looks like hardware. It is a representation of an actual program. So your database server is a program that runs somewhere. Oftentimes it's kind of an abstract concept. You rent a database server from a hosting provider. There's plenty that'll rent you a database, and they give you an IP address and a login, and you can access that database server. You don't have to worry about hosting it yourself. You don't have to worry about the server it runs on. But in the end, everything does eventually run on a server somewhere. So the database server runs somewhere. It contains multiple databases. So a database, I guess a good way to think about this is if you have multiple like folders on your computer. A database is kind of like a folder. And so the database server is your hard drive, and each individual folder is its own database. They don't nest. You can't nest a database inside a database, so the analogy doesn't go too well past that point, but you can look at it the same way. You may have a folder that's your user folder, and then you have another one for your documents, you have another one for your downloads, etc. You're not going to necessarily put your documents in your downloads folder, and you're not necessarily going to put like your gaming files inside your documents, right? Because you want to keep all these things together. If you have a family photos folder, you're just going to make sure all that data in there is family photos. So databases are similar in which the data inside them relates to the other data. Otherwise, you wouldn't be storing it there. Databases have a number of tables. And so if databases are considered to be the folders, tables you consider to be the files. So if you have a text file somewhere that you've written down a bunch of stuff on, that is equivalent of a database table. Now, database tables are stored in binary, and they are stored in a very efficient format, which makes them take up less space. So they can't be read by humans. It requires machines. It requires a database server to read them. But tables is where things start to get interesting because we usually work with a database in most projects, but it's usually we set up our connection stuff, and we forget about it. Not dealing with it anymore. It's done. So tables is really what we work with. We create tables, we modify tables, we insert data from tables, we pull data out of tables. This is where we start to get into the realm of things that we're really going to be working with. Each table contains a number of rows. This can be from 0 rows if it's an empty table to billions of rows. Though once you get up to billions of rows, the database system that we're going to be learning kind of starts to churn a little bit. There are other database systems that are designed to work with such heavy amounts of data, but a billion rows is a lot. Most projects in most startups don't get past the point where they have more than a billion rows of data. So what we're learning is usually what most companies use. The row is the actual data stored in the database. So if you're talking about a row, you're talking about the actual values. Everything else up till this point, databases, tables, database servers, has all been providing layers of structure around the data. But the row is the actual data that we're working with. So let's take a look at them. So a row contains multiple fields. Each field can be a different type of data. The table that the row is part of determines what the fields are and what their data types are. So this could be a user table, for instance. We see an ID field, which is numeric. We see a name field, which is a string, an email field, which is probably also a string, and then a date of birth, DOB, which is a date field. So MySQL in particular has some special field types. A date field, it doesn't get stored as a string. So you could store a string with, month, day, year, hour, minute, second, but that's not how MySQL stores dates. It stores them as a timestamp, as a number. But because we've told it it's a date, it knows that we probably don't want that. Like, we want to treat it like a date. So you can do a bunch of things that you would with a date on this, even though internally it's storing it as a number. Same thing with Booleans. We have true, we have false. MySQL doesn't store them that way. It stores them as bits. But externally, as we're using it, we don't have to think of them as bits. We can think of them as fully formed fields because the database server takes care of that for us. So let's take a look at how we would actually do some of this stuff. So MySQL is the client that we're using. Or the server that we're using. It's relatively easy to install on your computer. So the way you access it, if you're not using a connector, like in JavaScript, which we'll probably go over in another video, and your server's running, which actually mine is not, I'm realizing. Well, let me just show you what that looks like. So I say MySQL-u root-p, and I hit enter. And it says enter password. I don't have a password on this server. The U is the root, and the P is for password. I don't have a password. I'm just going to hit enter. Oh, never mind. My server is running. How about that? If you get an error at this point, it says it can't connect to the local socket. That means your server is not running. If you need to connect to a remote server, you can actually do it just by putting, like, if I put localhost here, it's going to connect to the localhost server. Oh, nope, that's the database. Never mind. There's a way to do it. I'm not going to go into it too much now because I don't remember off the top of my head. So in here, this is the MySQL server. It's kind of interesting. You notice the prompt has changed. Most commands we run, when we run them, they do their thing and then they're done. They dump us back to our command line. This one, it's left us here on a different kind of prompt. It's because this is the SQL prompt. We can start issuing SQL commands from here. So what is our first command? Well, remember I said that databases are like directories. Well, in a normal system, we would use the ls command to see all our directories. In MySQL, it's a little different. Show databases. Let me actually make that a little bit bigger. Show databases. Semicolon. Semicolon is really important in MySQL. Let me show you what happens if you don't put that in. Another thing you might notice is I put capital over here and lowercase here. For its actual keywords, MySQL does not care about case. You can do uppercase, you can do lowercase. Some people strive for uppercase because it makes it clear what is a MySQL keyword as to what is it, as opposed to a table name or data or something like that. You can do whatever. But I type this, and as soon as I hit enter here, it's going to try to send this to the server. Except it's not. You can see it does this little arrow here. I haven't given it a semicolon. And so MySQL is saying, oh, you're not done. You just wanted a new line because you wanted more space for some reason. So I put a semicolon here. It tells SQL that command is done, send it to the server. Now you can see it listed my databases. This is how the SQL client outputs data. Always in this nice little table format. There are 4 databases in here already. These are all system databases, even though only one of them is named sys. These are internal databases from MySQL that it uses to track its own data and figure out how that's going to work. We don't have any of our own databases in here. If you don't see all of these when you run your MySQL, that's okay. Different versions of MySQL handle things differently. So, oops, I don't actually want to save this. Let's say we want to create a new database. Well, in the command line, we would use mkdir for that. In SQL, we use create database and then the name. So I'm going to call this testDB. Okay, notice I end with a semicolon. I'm going to copy that, paste it over here, enter. And it tells me query OK, 1 row affected. It's giving me some statistics of what I did. It's telling me, hey, what you just told me to do, I'm okay with that. I did that, and it changed 1 row. Well, why would it be changing a row? I'm creating a database. Well, because databases are actually stored inside these other tables here. MySQL uses MySQL to store information on MySQL. Kind of fun. So if I run show databases again, you can see now my testDB shows up there. Okay, all is well. Let's say I want to get rid of it. And this is something that you should only do if you're very sure, and you should probably never do this in a production system. If you want to get rid of a database, in the command line, we would use rm or rm-rf to get rid of a database. Here, we say drop database and then the name of the database. So if I copy that, put that in here, you can see again, it says query OK. And this time it says 0 rows affected, which is a little interesting because we probably affected a row, but that's just how it's set up. I run my show databases. Oh yeah, also the arrow keys work here, up and down arrows to move through your previous things, similar to your terminal. Enter here, and you can see testDB is now gone. I'm going to recreate it. All right, and so now, if we want to enter a directory on our terminal, we use the command cd. In SQL, it's use. So we're telling SQL everything I do after this point is relative to this database. Use testDB. It now says database changed. Okay. If you want to find out what database you're currently looking at, in the terminal we use pwd. Here you can say select database like this. And this is probably a little confusing why we're doing this, but it will make sense later on. So you can see that it says, hey, your database is testdb. Now let's say I want to go into the MySQL database. Do I have to cd up? So in the terminal, we have to say cd and then 2 dots to go up a directory. You don't have to do that in MySQL. If you just say use again, it just knows that you want to go to another database, because remember, you can't nest these, so there's no need to have all that complexity. If I just say use MySQL, it changes it. I run select again, it says, hey, now you're in the MySQL. So now that we're in this database, we can look at the next thing. If you want to say show databases to find out the tables, well, you're going to get the databases again. If you want to do an ls of your database and see what tables are in it, you use show tables. And you can see this one, because this is an internal one, has a lot of tables. These are all the different tables that you can execute on. Let's go back to our testdb and run it again. Show tables. Don't forget your semicolon. Empty. And it tells us empty set. There's nothing there. There's no rows. Well, that's because we haven't created any tables. All right. So let's take a look at how we would do that. So to create a table in SQL is not super complicated. It starts with, and you know the SQL starts to do a lot of plain English. Create table, table name, user table. Well, let's just say user. Okay, and then parenthesis and a semicolon. Now, if I do this, I'm going to create a table without any fields. It's just going to be a completely empty table. That's not very interesting. So let's look at some data. So what we do in here, if we want to put fields, we have to tell SQL the name of the field and then the type of the field. So let's say we go back to our previous example. We have user, name, email, and date of birth. I could say ID. It's an int, comma, and you don't need the new line here. It's just nice to do because it makes your SQL look better. Name. Now here's the thing. SQL doesn't have a string. So if I say string, it's going to get confused. It has 2 different fields. It has text and it has varchar. So I could say text and then varchar. So what's the difference? Text is unlimited in length. You can put as many characters as you want into it, kind of like you'd expect, right? Varchar, on the other hand, it actually has parentheses around it, and if you put something in here, that field can never have more than 60 characters in it. Why would MySQL do this? Well, if it knows beforehand the length that a field is ever going to be, it can actually use that to store the data more efficiently and actually recall it more efficiently. And there's a lot of reasons for why that is that I don't want to go into right now because it's complicated. But if you use text, it just means that SQL is going to be, or MySQL is going to be less efficient when running queries over this table. For smaller tables, it probably doesn't make that big of a difference, but when you start getting tables with tens of millions of rows, then it starts to matter a little bit more. So keep that in mind. If you've ever got something that you say, well, there's probably never going to be more than 100 characters in here, for instance, then it's better to use a varchar than a text. In fact, I'm going to pop this up here. All right, so then let's say that you want to do DOB. There's a couple different types of fields for date. There's date, there's time, and there's date time. What's the difference? Well, time is literally just a time. Date is just the date part. So it's a little more efficient because it only has to store the date. Date time is both. So if you want to store an event that happened on the 12th of February 2021 at 6 p.m., then you need a date time. If you only care about the 12th of February 2021, then all you need is a date. Date of birth, we don't normally care about the time, so I'm just going to go with a date here. So let's copy all that in. Again, you don't need this white space here. So you actually could do it like this, except it looks awful. Like, so this is a valid query, just as same as this is. It just looks terrible. So I'm just going to do it this way. And you notice SQL, if I say create table users and then just hit enter here, because it hasn't seen the semicolon, it'll give me that little arrow. So if I copy this, paste it, yes, paste anyway, you notice it's done a bunch of little arrows here. It said, oh, clearly you're not done. Oh, clearly you're not done. You're not done. You're not done. You're not done. I get here, this line has a semicolon. So this will run. Okay, 0 rows affected, which kind of makes sense because we're not affecting rows. We're doing tables. So let's show tables again. Users. Now we see tables and TestDB has that user table. An interesting thing is, let's say you want to find out what this table was created with, like how it was made. You can use show create table users. And this will actually give you, and you can see it's a little different because SQL is actually generating this. It doesn't remember the exact query that you gave it to create that table. It's just generating it, saying if you wanted to recreate this table, this is how you would do it. So this can be kind of useful. What is the int 11 here? The 11 here it's not the same as the varchar. So for varchar 100, the character can't be bigger than 100. We can't have more than 100 characters. For an int 11, the 11 is an internal thing meant for display. So if we request that integer, MySQL is going to use 11 different character or 11 spaces to display that number by default. So this doesn't have any effect on the actual data that goes into it. So now we've created a table. How do we get data into it? So we get data into a table by using an insert query. So all of these are technically queries, in that a query is something where you send some text to the SQL server and it sends you a result back. In this case, my query, show create table users, resulted in this. And actually, see if you can make this bigger, you can see it starts to look a bit better. For really, really long fields, SQL doesn't always display them super well. So you can see like this is actually supposed to be all one field, etc., etc. It's okay. Just make it bigger if you are having confusion with what's going on. So we're going to do an insert query. Insert, okay, we start off with insert, makes sense, right? Then we have to tell SQL where to insert to, because there could be 50 tables on here. Into users, so the table name, okay. Then we have parentheses. Then we have the columns to insert. Why do we do this? Because SQL needs to know what data goes where. If I just said, okay, 1, Bob at bob.com. And then, okay, 2022, well, we should probably use this string. 5. These are all strings. MySQL is smart enough to recognize this is a date, but it doesn't know what these are. It actually doesn't know what a name is either. We didn't tell it this is an email, this is a name. We just said that's the name of the field. So SQL doesn't actually know which one of these is the name and which one is the email. If you ran it like this, it probably would just guess. It would say, okay, this is first field, second, third, fourth, and it could kind of figure it out. But we don't necessarily want it to guess, because if it guesses, it might guess wrong. So the first thing we're going to do is we're actually going to give it the columns that we want to insert into. So ID, name, email, and DOB. Okay? So this is saying, okay, we want to insert into users, and I'm going to be giving you data, and this is the format that data is going to be in. Then the next thing we do is we say, okay, here's the values I want you to insert, and more parentheses. So let's insert ID, Bob, gmail.com, 2022, 14/5. Well, that's not a right. That's not a good date. Semicolon. Let's run this. Query OK. 1 row affected. Cool. We can also insert multiple. So if we insert, like, let's say we wanted to insert N, and then I want to insert another one, I can put a comma and do another set here. And both of these rows will be inserted. And you can keep doing this as long as these fields must all fit this same pattern. This is a nice way to put bulk insert data because it's sometimes kind of expensive to go and query a server. So I insert this, and you notice because I had a new line there, it does the little arrow and it says, okay, I know you weren't done because you didn't give me a semicolon yet. Enter that and it says, hey, 2 rows affected. Interesting here, it says record 0, 0 duplicates. If I had inserted the same row twice, it would have told me, hey, you duplicated a row here, which is kind of useful to have in some cases. Okay, so now we have data in the database. How do we get it out? Well, similar to how we did our select database here, to get data out of any table, we use select query. Now, the first thing we want to do is we want to tell SQL what data we want to get back. Sometimes you want the whole table, but sometimes you only want a couple pieces. So I'm going to say name, email, DOB. Those are all the columns. Next one is we want to tell SQL where we want to get it from. From users. So this actually makes a lot of sense, right? Select ID, name, email, DOB from users. That's almost English. Copy that in here, paste that in here, and there you can see all of our tables, or all of our rows. Pretty cool. If we inserted another row, it would show up here. All right, so now we've got this select query, but we don't want everyone all the time. So like, let's say a user's trying to log in and we have 1 million users. We don't want to have to grab 1 million users out of the database and then in JavaScript or whatever your backend server language is, figure out what user we were actually trying to log in as. That wouldn't be great. So what we can do there is we can actually filter these. MySQL is really good at filtering data. All we have to do is say where, and then tell it what we want to filter on. This actually takes a very similar format to an if statement or a conditional in other major languages. So I could say, okay, where, let me see if I want to find Bob. Where Bob, or whoops, name, so I tell it the column I want to search first, or the field, equals Bob. Now something to note here, most high-level languages use at least a double equals, and some of them use a triple equals for equality. SQL doesn't. The reason that other high-level languages use a double equals is because single equals is for setting something equal to another thing. In MySQL, if I'm doing a select query, I'm not changing the data. It's not even possible. So if I get to this equals here, SQL is not going to say, oh, there's a possibility you want to set the name to Bob, because that's a totally different query. It knows that if it sees an equal, I'm just saying, hey, name equals Bob. Verify that that's true. So I only need the single equals here. Okay, so if I copy this, I only get Bob. Okay, well, there's a couple other things we can do here. I can say where ID is greater than 1. Put that in there. Now I get 2 rows back. So a where clause, it basically takes a slice of the table. You could do multiple too. Like let's say, let me just do another insert query here. I want to insert another AN. Okay, let's insert a second AN. This is AN2 into our database. Okay. So now if I do my select query again, I have 3 rows. Okay. So let's say I don't want AN in here. I'm like, there's too many ANs in this. But I still want this ID above 1. I can say and name equals Jerry. Oops. So I paste that in. Now I only get Jerry. Of course, I could have done this by just name equals Jerry. But you can see this is a compound selector. It filters first on the ID, then on the name. You can filter and do as many wheres as you want. Let's say I want to get people where the ID is above 3. Or it's Bob, because I like Bob. Or name equals Bob. I can do an or, which means, if you remember from conditionals, the or means either one of these can be true. So either the ID is above 3 or the name is Bob. And now you can see I get Bob, but I also get Ann because Ann meets that first criteria, Bob meets the second. You can nest these as well with parentheses, so I can say like, okay, name equals Bob and ID equals 2. Oops. Well, that's only Ann now because Bob's ID is 1. So this condition doesn't succeed for Bob. The where clause is pretty important, and it's used in a bunch of other queries as well. It's not used in the insert query. The insert query is kind of insert this data, but it's used in all the other queries. Okay, so let's say I want to do my select. I'm like, okay, select ID, name, email, DOB. Let's say there's 30 fields on this table. That's a lot of fields. So what I can do instead is I can just say select star from users. What does that do? The star matches every single field. So if I say select star, you see it still brings every single field out. And if I don't want that, if I just want the ID and the name, for instance, I can just grab this and say here, and you see it only returns those 2 columns. Only the columns I list, but if I give the star, it just lists them all by default, which saves you some typing. Okay, so let's say at some point Bob shows, or not Bob, Jerry comes and he goes, hey, my date of birth is not this. This is not my date of birth, actually. I was born in 2020, which if all these people were born in 2022, they're not talking at all, probably. Well, maybe they are. Who knows? For the sake of our hypothetical example, they can. So Jerry's saying, hey, can you update my row to have accurate data because this is embarrassing? Okay, sure, we can do that. So let's say we're going to update. Update, and then table name, users, set, and then first the field name. So now here in this case, the equals does mean equality. So I could say set DOB equals 2020 515. And now, again, you can have, if I run this query, it's going to set every single user's date of birth because it's going to match every single user. I want this to only work for Jerry. Well, the quickest way to do that is on the ID, so I can also say where ID equals 3. Now note again, even though we're able to update with the single equals here, MySQL knows because we've seen the where, anything in the where is going to be a check for equality, so we can still use the single equals here. It's smart like that. So I put this in here, and this is where something becomes important. One row affected, changed one, and one matched. That's important. Because if you run a query like this and all of a sudden you see 10,000 rows matched and changed, that might mean that you forgot your where clause or you didn't set it up properly. So let's run that select again. And now we can see Jerry's date of birth is changed. Any field can go in here. If I want to do multiple fields, like let's say Jerry says also that's not my email. Well, let's do this. Let's say for this, for Ann, Ann says, okay, that's not my date of birth and that's not my email. Users set date of birth equals, and Ann, turns out, is slightly older than Jerry. We put a comma, and then we can do another field. Email is going to be Annie.com, where ID equals 2. Here's the other thing we can do. If we're like, yeah, the ID should equal 2, but we're not totally sure if that's going to match, we can also put limit 1. And what limit 1 does is it just tells SQL as soon as you've updated one row, stop, we're done. I don't care, more match. It's a nice, healthy safeguard in this case. So, update users, set DOB, 18, comma, email. You could do another comma if you want to do another one here. As many fields as you want to update. We run that. Again, matched one, changed one. Run our select again, and now we can see Annie's email and date of birth have changed. So now we're doing an audit across our system, and we realize that this second Ann in here shouldn't have been set up. This is actually the same Ann as in ID2. We just gave them 2 accounts accidentally. Which, you know, maybe Ann's okay with that, but our system administrator is not. So they say, hey, You got to get rid of user 4. User 4 is a duplicate. We just can't have them. We need to delete that row. Okay. Delete from users. Where, because if we just run delete from users, this is going to delete every single user. We don't want that. That would be a really bad thing. This is, again, where limit 1 can be really useful, because if you run a query like that, then at least you only screwed up one user. Where ID equals 4. Again, this where clause is the same as this where clause. You can put a very complex compound thing in here. Usually it's very simple, but you can have an extremely complicated where clause on update and delete as well. So I'm going to put limit 1 in here just in case there's more users. Put that in here. 1 row affected. That's what we expect. We do our select now, and is gone. So this is the 4 different types of queries. You have your insert, you have your select to get data back, you have your update, and your delete. So those form what we call CRUD, create, read, update, delete. CRUD is a pretty common acronym for just a bunch of common things that you might want to do on a table. So here's a thing that could be kind of interesting. Let's say that I accidentally run this query. Let's do another 4, right? Let's do 4, and this is going to be Betty instead. Okay, so let's say I run this, right? And I accidentally slip up and I run it again. Oh no, now I've got 2 Bettys, and this was the whole situation that our admin was upset about. Now here's the other problem. They both have the same ID. So if I try to run an update query on Betty, it's on ID, it's going to update both. So let's try that. If I say, okay, let's update users, set DOB equals, let's see, 16, 15, where ID equals 4, it updated 2 rows now because they both match. It'd be good if the ID was unique, right? That'd be real good. Okay, so how do we do that? Well, for ID especially, and I'm actually going to, what we're going to do, let's delete our table. Let's start over. Let's say this table, no good. You know, the ID can be duplicated, runs into all kinds of problems. We're just deleting it, start over. Similar to drop database, there is also drop table with the name of table. Again, this is something you should do very carefully and probably never in production. If I say drop table, and now I try to select from this table, SQL says, hey, your table's not there. You got rid of it. What are you talking about? Okay, so we want our ID, let's say, to be unique. So there's a couple ways of doing that. The thing that we want to do specifically for IDs is not only make it unique, but also make it so that we don't have to enter it anymore. Let's just let MySQL handle the whole thing. So how do we do that? After int, after the type of the field, you can put different data on how that field should react. So I can say, and this is a special thing, auto increment. Now, what auto increment does is it tells MySQL, hey, whenever you insert, and if someone has not provided an ID, generate one for them, and just keep incrementing it. So let's try that. Paste anyway. MySQL says, hey, no. There can only be one auto column. It must be defined as a key. What is a key? That's an interesting thing. What's an interesting idea? So keys are something in SQL where if you define a column as a key, it keeps that column's data in its memory banks. So right now, if I say select star from users, or I say where ID equals 4, MySQL actually has to do a full table scan of everything in the table to find where's ID equal 4, where does ID equal 4? Oh, I found one. Okay. If there's 1,000,000 rows, it goes through 1,000,000 rows. Why does it do that? Well, because it doesn't know how many rows might match until it looks at them. If you define a column as a key, SQL actually keeps that list in memory. So then if you say where ID equals 4, it looks at that memory and it's basically using like a JavaScript object. It says, oh, 4. Yes, I immediately can look up and I know what rows belong to that. So it allows it to look up much more effectively what's going on. So keys, if you're finding that you need to do queries on certain data very commonly, it's a really good idea to make it a key, or an index at least. Keys and indexes are kind of interchangeable in a lot of cases, except when they're not. So, but all keys are indexes. I guess yeah, all keys are indexes, but not all indexers are keys, if that makes sense. And the differences between them isn't super important for what we're going over right now. Maybe we'll do that in another video later. But anyway, JavaScript, or not JavaScript, MySQL is saying if you're doing an auto column, it has to be a key. Well, how do we do that? We can define it and just say like, there's a key on ID. Cool, there's a key. But for auto increment columns and ID specifically, we want to actually say to MySQL, this is the main key. When I'm looking up stuff, I'm almost always going to use this key, this field. So after auto increment, I can say primary key, and that tells MySQL this is the primary way of looking up data from this table, which allows MySQL to index things and optimize the way that it looks up stuff. So let's try that. All right, paste anyway. Nope, semicolon's already there. And there it is. Show table. Okay. So now let's try that insert again, except I'm going to do something a little different. I'm going to take out the ID. Okay, and I'm actually going to put this on new line. All right, and then let's do a couple more of these. So let's do Betty. Let's bring back Bob. Bob was a good sport. Let's bring in Tom. All right. So we don't have an ID. What's going to happen with that? It's going to be null? Well, let's see. So if I take this and I paste it in here, and then we hit enter, it inserted 3 rows. Okay, so let's select star from users. It put IDs in for us. And that's what auto increment will do for you, is not only does it make it so that you can't have a user without an ID, it also makes it so that it inserts it for you. So let's try to insert another user with the same ID. So let's say we insert 1, and we make this one Kate. Oops. Okay. MySQL says, oh, nope, because I didn't put ID in here. That column count doesn't match row count, means that you have too much stuff in your values and not enough in here. They always have to match, 4 and 4 in this case. Okay. Okay, now you can see. Oh, you can't see that because my camera's over it. So, duplicate entry 1 for key primary. I can't add another user with ID 1 at this point, which is exactly what we wanted. We only want 1 ID per user. So that's something that a key is really good for doing, is it makes sure, especially a unique key at least, it makes sure that you can't put duplicate data in. All right, so let's say now that I'm inserting a new person, but I just forgot to put in these parameters. So I got fed up and I'm like, fine, SQL, have it your way. Here's just the name. Okay, put that in here. Okay, SQL's happy with that. And now if I, oops, from users, well now there's no email, no date of birth. Maybe that's okay. Maybe it's all right for there to be no date of birth in our system, but email's important. Our system administrator comes down to us again. They're like, hey, someone doesn't have an email. This is a problem because now they can't log into our system. Your table's screwed up. All right. Well, let's drop our table again and let's fix that. So there's a specific thing to do in MySQL, and we actually kind of saw it a little bit further up when we actually did the show created with, is that we can by default, these fields can be null. If we want them to not be null, we actually have to tell MySQL, okay, not null. And what that does is that tells SQL, hey, this can't be null. Let's do it to the ID also, just, just to be safe. It probably doesn't matter too much because, it's already not null because it's a primary key, but just in case, just in case. All right. So now we have our ID, not null, our name, sure, let's leave that, that can be null. Email, not null, and date of birth. Okay. So now, let's create that table. And now let's try to do our insert. Actually, I'm going to make this one line because might as well. Oops. Not like that. All right. Field email doesn't have a default value. What that means is that all these default to null. We've told this, hey, this should not be null, right? We can't handle this, so we have to give an email. And then once we do that, we should be able to insert. And now I got to backspace it all. Users. Okay. Now you can see our date of birth is null. Totally fine. What if we want to have a default though? What if we want to say, okay, we've got another field here called city. And it's a varchar. And it's 100. But most of our users come from San Jose, right? So if there's no entry for the city, we want it to default to something. We can actually say default San Jose. This is not the greatest example, this city. I don't want to drop my user table. I don't want to get rid of this user table because I have user data in there. Well, luckily, there is actually a command, alter table users. And then we can add a new column by just saying add city varchar 100 default, default San Jose, California. Put that in there. And you can see, oh, okay, it added a new row or add a new column. We didn't have to drop our table. And now if we do a select, you can see it added the column. And what happens if you add a new column is that for every user that's currently, or every row that's currently in your table, that default gets used for them. So if this didn't have a default, it would have set to null. If you do add a new column and you say not null, and you don't provide a default, well, then you can't alter your table because it couldn't update the columns in an intelligent way, which usually whenever you're adding new columns, they're almost always nullable columns. So now, let's say we insert Jen now into our table, and we do our select. Well, now Jen also has this default because that's the default value. Date of birth doesn't have a default value, so it gets null. City gets this. ID becomes 2. So there's a lot of other stuff that you can do with SQL. There's table joins. There's foreign keys. There's aggregation, groups, all that stuff. But this is the very basics of how to use it. I know this is really long, but I hope it was helpful, and I'll see you all in class.